Hey there! Here we go into finding derivatives of inverse trig functions. And as scary as the formulas look, it really is all about memorization and plug and chug for almost every single calculus class out there, including even on the A, B, and BC exam. Now with that said, you know I'm not about just straight up memorization, so in a later video, I'll go over where these formulas come from. But first, in this video, I want you to be comfortable with the process and to see that the functions actually have some patterns to them. So here are the actual derivative functions for every single inverse trig function there is. I use arc notation instead of saying sine inverse, but you could easily have been given something like this, sine inverse of u over a. Now please note that my formulas are going to be a little bit different than what you will see in most textbooks and in most classes. I do that so that when we get to integrating, it makes a lot more sense, because I think a lot of people bungle this stuff. And I'm going to show you the connections between it all. All right, so the derivatives of inverse trig functions. Well, y equals arcsine of u over a. Its derivative is u prime over the square root of a squared minus u squared. Notice how Pythagorean that looks, right? It looks like something out of the Pythagorean theorem, something squared minus something squared. That's not coincidence. It's beautiful. U prime is the chain rule. That's it. For arctan, similar, but you've got a different kind of Pythagorean scope here. You've got a squared plus u squared with a up top, u prime. That u prime is going to be in all of these. That's the chain rule. And then arcsecant, which is very rarely asked. If you have one of those teachers that does ask it, just make sure you memorize it, is a u prime over absolute value of u. And then it's the reverse of sine, which makes a lot of sense if it's the reverse of sine or cosine, you'll see, because it's the reciprocal. So it ends up being root u squared minus a squared. So you can see patterns there, how there's some similarities and differences. They're all pretty Pythagorean though. You got a little bit of a squared plus b squared equals c squared in each of these. Now, arc cosine is the same exact thing as arc sine, it's just the negative version of it, which makes sense. The derivative of cosine is negative sine, right? And that's not coincidence again. Arc cotangent of u over a is the same exact thing as arctan. Again, just the negative. And our cosecant, the same exact thing. So they're all the same as their counterparts. So you don't have to memorize these three, except for just know that they're the negative versions of their counterparts. So know those three. In general, the most popular things that are asked in the A, B, and BC exam are arcsine, arc cosine, and I put arc cotangent there. I'm going to erase that and say it's actually arctangent. I've seen arctangent, not arc cotangent. All right, so those are the three biggies, with arcsine and arctan being the two biggest, for whatever reason. Okay, so on to the next bit here. We're going to actually employ these derivative formulas. You're going to see how easy this is once we have the formulas down. So my recommendation when you practice this is write out the formula each time. Identify what u and a are, and then go to town. So the derivative of arcsine in general, so f prime of x is going to be equal to, we have u prime all over the square root of a squared minus u squared. Okay, so we have that. Now I put this over 1 if it's not over 1. So now we've got that we have u over a. So u is essentially x squared minus 5, and a is basically 1. Now let's go to town. So the derivative overall is going to be u prime, that's the chain rule part, that's 2x, right? So that's 2x all over, square root of a squared minus u squared. Well, a squared is just 1, so it'd be 1 squared, minus u squared, so that'd be x squared minus 5. So x squared minus 5 squared. As ugly as that is, that's your derivative. It's not so bad though, right? Not so bad, it's just plug and chug. Arctan. So again, the derivative of arctan, or tangent inverse, is going to be a u prime. I would say, ow, like it hurts, right? So a u prime all over a squared plus u squared. Now, what's u and what's a? Well, u is up at the top, a is at the bottom. So now we plug and chug. So a is 6, so we're going to get 6. U prime, well, u prime is just 1, right? Because the derivative of x is just 1. All over, a squared is 6 squared plus u squared, which is x squared. And so that's going to end up being 6 over, and this will be 36 plus x squared. And this might look slightly different than an answer that you get with the formula that you use from your textbook or your teacher. Rest assured it is equivalent to whatever you're getting. And again, I do it this way with a slightly different formula because when we get into the integration, it's going to make a ton of sense and it'll connect. All right, arcsecant. Ooh, what's arcsecant? Well, the derivative is going to be equal to, the same as with tangent, au prime all over the absolute value of u times the square root of u squared minus a squared. It's kind of like the flip of this. All right, so you got that u squared minus a squared. And now from here, we just plug and chug. Well, again, u is equal to this top function. A is equal to the bottom function. It's always going to be that way. So a is 2. U prime is the derivative of x cubed, which is 3x squared, all over. Now we got to plug in our values. The absolute value of u would be the absolute value of x cubed times the square root of u squared. So we're going to square x cubed, and then we're going to subtract out 2 squared. I'm just plugging and chugging, and then I'll go and simplify in this step. 2 times 3 is 6 in most nations, so it'll be 6x squared, the absolute value of x cubed, times the square root. X cubed squared is x to the 6th minus 4. And that's your formula. So at the very basic of all of this, you need to memorize the formulas. Look for the patterns that are in those formulas that I went over and just apply them. They're not bad. As always, all of these functions still give you the slopes at whatever x value you're plugging in. They're no different. It's still the derivative, just a different function to take the derivative of. All right, I'll see you in the next video where if you need to know the why or you're curious, I'm going to show you where these formulas come from. And you could actually use that process instead of memorization if you prefer. My advice, memorize the formulas and use them. All right, peace.